Variance and standard deviation are very important in data science or in mathematics or even just generally analyzing and understanding data. And I see that a lot of adults have forgotten what exactly how do you get the variance and the standard deviation of something. And they're pretty straightforward. So I'm going to remind you, show you how, why in a very quick, short video here. So we're not going to start with the formula itself. We're going to build up to the formula and you'll understand exactly why. So let's say that you have some data and that data is, you think it's normally distributed and you're going to find the standard deviation and variance of this data. So how do you do that? What you do is you take all the data points and you want to see how different are they from the average. That's essentially what variance is all about. It's how different is something from the average. So let's say that we are talking about human heights. So maybe a short person is like 4 feet tall, and maybe a tall person is like 7.5 feet tall. And somewhere in there, maybe the average person could be, let's say, 5.5 feet tall. Now, of course, if you are talking about different cultures, the average would be different. For example, if you were talking about Swedish people, they might be taller than the average person, and their average might be 6 feet tall. So depending on the culture and the place, the averages may be different. But let's say that we have a population where the average person is, let's say, 6 feet tall. So in this population where the average person is 6 feet tall, the how do we know that the average person is 6 feet tall? Let's say that the population, we sample a part of the population, and what we do is we add up the heights of all the people in our sample and divide by the number of people in the sample. And that's how we typically get an average, and I'm sure most people do remember that. So let's take a very simple example of this population with a average of 6 feet tall. So maybe we will say that there's a person that is 4 feet tall, a person that is 3 feet. Okay, let's not do 3 feet. That I'm not sure there's too many people at 3 feet. Let's do 4 feet, 5 feet, 6 feet, 7 feet, and I want to make the, okay, if I take this 4 set, it'll be 5.5 feet will be the average. So let's just have, let's say there's a really tall person at 8 feet in this population. So now you can see clearly that the average is 6 feet. So how different, or what is the spread like of this population? So if I was to say that a person is 7 feet and 5 inches tall, then how different is he from the average? Well, your first idea might just be to subtract the average. So you might say, hey, a person who is 7 feet tall is 1 foot different from the average. So it's 7 minus 6. And then if a person is 5 feet tall, then he is 5 minus 6. Well, so in this case, the person is 1 foot different, and in this case, the person is minus 1 foot different. But we kind of want both to be the same, right? Because we're just trying to see how different is this person from the average. And so there's two possibilities. One possibility is that we square the 1. And so if we square the 1, then we're going to get the same in either case. So we can get a 1. The other possibility is we can take the absolute value And if we take the absolute value, we can also get a 1 on either side. So these are two ideas that we have about how we might make both sides the same. Now, we want to kind of figure out this metric of how different something is. So, but we don't want to do it for one specific individual. We want to do it across the board. So let's say we took all of the differences from the average. So we're going to take 4 and 6. So that's going to be a difference of 2. Minus 2, minus 1, 0, 1, and 2. These are the differences. Now, if we were to square all of these differences to make both sides equal the way we just said, we are going to get 4, 1, 0, 1, and 2. And then if we were to add these differences up, we would get 2 plus 2, 4, plus 4, 8. And that's interesting, but now this 8 is not telling us the difference for kind of averaged out across all of these points, but more like a specific, it's kind of the total. So we want to divide this by 5. And that's exactly what the variance is. Now, what would be the other case? We said if we took the absolute values instead, we would have had 2, 1, 0, 1, and 2. Sorry, this should have been a 4. And so this one will be not 8, but 8, 9, 10. So 2. So the variance is 2. Now, if we had done the absolute value way, we would have got, let's see, 4, 5, 6 over 5. So this method here is going to give us something that isn't as reflective of the difference. And so what we would like to do is probably go with the square. And if we want to normalize it because we took the square, so this one is called the variance, then we can also just unsquare it and basically take the square root of it, and that is called the standard deviation. So essentially this, what we just represented as a formula, then becomes the sum of each of the xi's, which are the 4, 5, 6, 7, 8 here, minus the mean, which is in this case 6, which you calculate by adding up all of the numbers xi's and dividing by n, and then dividing this whole thing by n, and that's the variance. And the standard deviation then is just the square root of the variance. And that's all. That's how you calculate the standard deviation and the variance of a sample from a population.